Okay, let's see if the fourth time is my charm. I am sorry, guys. I'm just having internet problems and YouTube problems and iPhone problems. I miss room 313. I miss you guys so much. I miss my classroom. Anyways, when we ended off, I was doing 3 times 0.013 or 123. And when I added them up, I ended up with 0.69. And you can't have 0.69 of a face card, so you're going to get approximately 1 face card. Now, this scenario works great. The old way, using the chart, works great. But you might not always have all of this information. So I want you to take a look. We've got a little quickie formula for expected value that can be used only with Bernoulli trials. And watch and see what happens. Your N represents your number of trials, and in this case it's 3. Your P represents your probability of success, which is 12 over 52. Top by top, bottom by bottom, 36 over 52. Look at this. Exactly the same answer, which is approximately 1 face card. So you're expected, if you were going to play this game over and over and over based on averaging, your expected number of face cards would be to get approximately 1. Now notice it could go in between the 0 and the 1 because of the way this is. But for answering purposes, it's a beautiful 1. Okay, let's try to get the last page done here so that we're not on to 5 videos. A manufacturing company produces engine parts. It's estimated that 3% of the parts are defective. What is the probability that exactly 2 defective parts if you've got a random sample of 25? So again, this is a Bernoulli because there are 2 outcomes: defective and not defective. So I can run Bernoulli, and Bernoulli says number of trials, 25. Number of successes. Now, it seems kind of weird to think of being a defect as being a success, but that's what's being measured in this question. So, number of trials, 2 defects. Probability of defect, 3%. You have a choice. You can write that as decimal 0.03, or if you wanted, you could also write this question as 3 over 100. To the number of successes, or in this case, the number of defects, all multiplied by the probability of failure, 97%, to the number of failures. Now that 97% can be 97 over 100. So either of these will be accepted. If you like everything in decimals, by all means, keep them in decimals. So probability of being a defect, 3%. Probability of not being a defect, 97%. And remembering how to convert, your percentages to decimals. You don't want to lose marks for that. Run it through my calculator, 13%. Now, what about this one? What is the probability of at least 1 defect? That means 1 defect, 2 defects, 3, 4, 5, 6, 7, all the way up to 25. You don't want to run Bernoulli that many times. So this is the perfect scenario for indirect or reverse site. And I'm going to use Bernoulli. 25 parts, 0 defects. Probability of being a defect to the number of defects. Probability of not being defective to the number of non-defects. Beautiful. Again, not spending a lot of time on calculator work. What is the expected number of defects? Now, again, I can't use the chart for this one. I don't have enough information. So my hand is tied, and I'm going to use my quickie formula where my N is my number of trials, and in this case, 25. And my P is my probability of success, or in this case, probability of defects. 25 times 0.03 is 0.75. You can't have 0.75 of a part, so it's approximately 1. Therefore, the expected number is approximately 1 part. Okay, things are looking good for my video. Let's go on to our last one. A company sends out a survey in the mail. The response rate is estimated at 30%. Find the probability in a sample of 30 that exactly 5 participate. So again, this is classic Bernoulli, because you either participate or you don't. You either participate or you don't. So number of trials, 30. Number of households that participate. Probability of participation is 30%, 0.30. Number of participants. Probability of not participating, 30% for participating means 70% just throw it in the recycle. And number not participating is 25. Calculator work, roughly 5%. What is the probability that at least 3 households? So that means 3, 4, 5, 6, 7, 8, 9, 10, blah, 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 all the way to 30. Don't want to do it that way. 0 participants, 1 participant, 2 participants, and that looks good. We're subtracting opposite to the question. Okay, so let's think about this. Number of trials, 30, 0 participants. Probability of success is 30% to the exponent of the number of successes. Probability of failure is 70% to the number of failures. Number of trials to number of successes. Probability of success to the number of successes. Probability of failure to the number of failures, 29. If I've got 1 success, 29 failures. Number of trials, number of successes. Probability of success to the number of successes. Probability of failure, careful, to the number of failures. Gonna get my calculator rocking and rolling. Ooh, these are all really, really, really small numbers. You're gonna see scientific notation for all of these guys. Okay. Let's maybe try one just so that you see it. 30, choose 0. 0.3 to the exponent 0 times 0.7 to the exponent 30. And that's scientific notation of 0.1234225. Okay. Actually, we can take the time. I'll do them for you. My video seems to be back up working. .0002897.9, and we'll try the last one. 30. Oops. Combination of 30, choose 2. 0.3 to the exponent 2. 0.7 to the exponent 28. 0.0 0.01808. And hopefully that works for you. I think it looks pretty good. Okay, what is the probability, given a sample of 30, that at most 17 households? Now, you've seen at most before. At most means the probability of 0 plus the probability of 1 plus the probability of 2, 3, all the way up to 16 and 17. That would require a lot of iterations of Bernoulli. I wonder if I did it reverse. Well, reverse would be 1 minus probability of 18 minus probability of 19 minus probability of 20 minus probability of 21 minus ... all the way to probability of 30. So either way, if you were asked this particular question, it would require quite a few iterations on your behalf. Okay? Again, sorry about the 4 videos today, guys. I don't know what was going on, but hopefully it works out and we won't try to beat that record again, that's for sure. Thank you.